14 are added. Very good. I was expected more. It'll be okay. Okay, we'll wait a little bit if there are more people. So did you manage to get the HTML file and the R file? Yes, no? Yes, 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 perfect. I will share my screen. Which one I will share? Yep. Could you see my screen or not really? I don't see my screen, but you will tell me. Can you see my RStudio or no? Yep. Okay. So I just opened my RMD file, but you have the HTML file and all of this. So let me know if you have some trouble, if somebody has some trouble to install the Keras package, because we will use the Keras package to get the data, I think. Yes, because the means data, so the digits data are from, you can get from different places, but the easy way is that there are already some data set which we will work on in the package Keras, and Keras will be like our tools to build some neural network and to run some neural network. Okay, should we start now? It's okay? Yep. Okay, we start. I try to see. Okay, I'm not so good in Zoom. I want to see in the same time the chat. If somebody writes something on the chat, I will see if I can read the chat, because I see the people, but up. Okay, I don't see the chat. Okay, yeah, I can see it. More chat. Ah, yeah, I got it. Okay, I'm ready. Yes, but it's very big. Okay, so my screen is very big, is it? So what is big? Is the font big?
It's just very zoomed, but I think it'll be okay.
The what?
It's just,
like
yeah, it gets better. That's better.
Yeah, like this?
Yeah.
Okay. You know, I'm a little bit old, I cannot see anything. Okay. So let's start, because we have plenty of stuff to do, but it will be okay. So today is just like, we not run any neural network or something like this. It's just to take some ability to look on some image data and to plot some image and to do some basic classifier that Yoni just presented just before. So we will do this classifier on different data sets. So the fashion mist and the means data. So everyone know what is this means data. So you managed to read your data. It's okay. So let me know if you didn't manage to read the data. So when I read the data, I have is like an array, and we have 60,000 digits, and is some image in grayscale. So is 28 by 28 pixel. So I have used the different option to plot some image data in R. And here I just, for the first part, I use the function image. And we can, is on the it's not on the Miss data. I'm stupid. Is it? Ah, is yes. Sorry, it's on the fashion Miss data. So we have 60,000 image, and I plot the first one. So is a tensor which is a 3-dimension, and in R is called an array. So the first dimension is 60,000 images, 28 by 28 pixel images. So the first, what is this one? Is a shoe. Okay, it's a shoe, yes. And we have in your data, you have in the, which it was in the Y, you have some class label, which is coded 0 to 9. And in fact, is a class. So you have some t-shirts, some trousers, some pullover, and so on. So I just define an object which is called closed labels with the name of each possibilities for the images. By the way, if do we have some people who doesn't never used R before, or everybody has used R? Can you let me know for 18 people if you can say yes, 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 or no, no, no? Yes, use, never used before. Okay, so Matt, let me know if I'm going too fast, okay? And try to get some help from you and ask some questions too fast. I have used R, so we have just one which I haven't used. Message, yes, 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 okay, okay. And do you all use RStudio to run R, or you just use a simple interface R? Because I suggest you to use RStudio, which is quite handy. Yes, okay. So we first talk to Matt. Matt, did you manage to run the first line of code from the HTML file or on the R file?
Yeah, I thought I installed Keras this morning, but I think I installed it into the main R GUI. And so when I just went to use RStudio, it said I haven't installed it yet. So it's doing that now.
Okay, so you know how to do from RStudio?
I'm learning, yeah.
So from RStudio for installing packages, it's quite easy. You have on the bottom right on the panel, if you see my screen, do this. You can do by click the, oh. Yes, so you can, if you see my mouse, I don't know, if you do package, you have install. If you could click on install, you see it here, install.
Yeah.
And it's open directly, it's going to the ground. And if you start to type Keras, and you know, you have plenty of options, is the first one, Keras, and just install.
Yeah. I copied your install.packages.
Yes, so in fact,
I typed that in and it's doing something. So
yeah, okay. In fact, when you do this with like a click button, it will run exactly install.packages. It's similar.
Yeah. Okay. Thank you.
Okay. So I will keep going to the first task. So the first task was, oh, I don't know to show. First task, present the second image of the training set in the same way as done for the first. Quite easy. Some people have some trouble to do the first task. Keras, you get fashion not found. Oh, very weird. Okay. did you, Peter, have you used library Keras first? Okay, we will do this. We will solve this trouble. One of them, I will stop to share my screen, and I want to see one of your screen. So we have some trouble to get fashion. Ah, yes, installation of TensorFlow not found. Okay. Are you working on Windows or on Linux or on Mac? Mac. Okay, so Mac will be okay. Windows, I don't like Windows, it's okay. So install TensorFlow. So the people who not say install TensorFlow not found, try to install TensorFlow from R, even for people from Mac and Windows. So Machine and Peter, I suggest to install TensorFlow from RStudio by using install the packages or by the click button. Let me know if it's working or not. Peter, could you show your screen? Share your screen?
Yeah, sure, just a second.
Just to see if it's working. Okay, try on the click button, install, on the right, on the, yes, here. Start to say TensorFlow, white tensor, yep, go, oh, yes, take this one, and start, yeah, yes. Okay.
When you install packages, you need to have the package name in quotation.
Yeah.
That was the problem.
Yes, exactly. But when you, yeah, thanks, Anne. But he managed to do it with. So now you got it. It will be okay now. Yes. Oh, you have an error. Step by step. Try to do library, the first one. No. Yep. Second, fashion, data set. That's it. This one. Run it.
That one there?
Yes. TensorFlow.keras was not found. You are on Windows, is it?
Yes, Windows.
Okay, detect Python configuration. You don't have maybe Python, I don't know. Okay, do library TensorFlow first. Yep. Okay, again now. Okay, can you try to put on the first line of code, error Python module TensorFlow was not found? Could you put on Google? So this is a good point to do it when you have an error like this.
So, sorry, what did you want me to click on?
You copy the message of error, this one, yep, and you put on Google.
And put it where?
In Google?
Oh, in Google, yes.
So for us who is working, we keep going to do the tutorial. Eh? You try to do it. Eh? Yes, try it, but I'm not so sure. Save it. Yep. Just try again to the library TensorFlow and after library Keras maybe. And library Keras. Yep. And now this, well, finger crossed. Yes, you try. You can install the phone is install the function. Okay. I don't know what is the function install TensorFlow. Can you do question mark? Question mark install. Yes, TensorFlow. Yep. Enter. So what to say? Ah, yes. Okay. Try to do. I checked what is automatically find a method. Okay. So yes, do just install TensorFlow. Just to do like this. Yep. Bucket. Yeah. I hope you will find the good thing to install. Yes, it will be better. Because Keras is a package from Python, so we use this one. So I think it will be okay. I will check on the Zoom. Some people are on the chat. Okay. Machine, have you tried to follow what he's doing? Because I can see that you have the same trouble. Okay. Okay, c'est un show version GPU. Okay, it's okay. Is still installing? Yes. Wait a little bit. Okay.
It might take a bit to download 500 megabytes. My internet's quite slow, so please continue, and I'll
Yes.
let you know once it's done.
Okay. Yeah. Okay. Good. Thanks. So the first task was to find what is the T-shirt, but I showed the solution, so it's not fun. No, the second one, yes. The first task present the second image, so the T-shirt. So everybody got a T-shirt. So we'll ask another task. Just give me the image 4. I want to see the image 4 and let me know what is the image 4. Okay, everybody is agree with Anne. Say a dress. Yes, okay, is a dress. Okay, good. We check if it's a dress. Up. So we just need to put a 4 here, maybe. 4. Didn't work for me. Good job. maybe I haven't run this. Yes, I have my choose, true, rob, boot, boot, and the fourth is a dress. Okay, nice dress. So in this data, we have the data are split in a train and a test set, and we just have a look at if the data are balanced, and you can see on the train set that we have 6,000 images from each from ankle boot, t-shirt, and so on. So completely balanced. So this is by doing a table, and so actually chat. There's something in the chat. Yep. Okay. And we do the same for the test. So what did you get for the test? We have also something balanced. So you managed to get something also balanced for the test. Yep, easy. So just change, instead to put table fashion train, you just do fashion test dollar. Okay. Okay, now we work on the means data. So the means data, to get the means data, you just need to do this line code, which is dataset underscore means, and we get the data, and that's the first task to do. We just have a look at the dimension of each object. So each object, we have the train set with the X and the Y, so the features, the image, the characteristics of the images, and in the test set, you have the label. And you have 60,000 images on the train set, and on the test set, you have 10,000 images. So the first thing to do when you have some data, image data, is to scale to 0, 1. So the pixels are 0 to 255. So for each pixel, we divide by 255. So our data, our features, X, each pixel is between 0 and 1. So keep in mind this for the images. So we did by hand, and you have some function later what they do for you. So I do this, and I check if the outcome if it's balanced or not. So it's not really balanced. So for example, we have more, which is digits. We have more, which is the one we have more is a 1. I'm going too fast, not too fast. Okay, no question. Still have no question. So me, I have one question. At this stage, we have everyone managed to get all of this, except the 2 students who have some trouble to install Keras and Tensorflow. Is it? So we have Mashid and Peter who are working on. Is it? Otherwise, all is good. Mashid, we say Mashid. Have you managed to solve your trouble or not? Okay. Okay, Peter seems to be okay. And I want a response to Mashid. It didn't work for me. I Google it and I am trying another solution. Okay. And you are on Mac, Mashid? Yes. Okay. So keep working on this, and if you didn't manage to get, I will take you just after the tutorial, okay? Okay, so Matt solved the trouble. So we have two. We need to solve with two people for the, okay. Okay, so I keep going. So we scale the data. We have seen that the train are not really balanced, and on the test set, also the figure which is more representative is the 1, 2. So I think Yoni show you this. So we just check a rough comparison of the training and the test set on for each images. We compute the mean all of the intensity of each images and the mean of all. So for each images, we take all the pixel and we compute the mean. So it give you, in fact, the intensity of each figures. So I just plot this. So is a meaning that, for example, the mean pixel intensity, the intensity is the bigger, the higher from the 0. And for the 1 is just a rough summary of all the day, all the 0, all the 1, all the 2, and so on. Everybody get this plot, and what is the meaning of this plot? Yes, is the overall mean for each. So when you do the question, it was what is doing this code. So is a loop. So each time for the digit, for example, it started with 0. So it collects all the, for example, here on the training set, all the 0. So this, which means this, it collects from all your data set just the 0, and it takes all the images and it takes the mean of the pixel. It's not for each, it's doing this for each image, but it is for all the images, all the 0. So this is the mean pixel of all the 0, mean pixel of all the 1, and so on. Okay, Peter? Clear? Okay. So now you do the same for the fashion mist, and tell me if you manage to get something like this. So maybe for the people who are very handy with R, it's quite a little bit simple. But work in progress, we go slowly, and we'll see at the end of the week or next week we'll be fast. So no stress, so we can relax for the people who are very easy on R. So I wait a little bit, and if I see a lot of yes or question, I reply, and I can give the solution. So you have to do the same for the means, fashion means. So first scale your data, and after try to compute the mean pixel for each categories of the images. So the uncle book, the bag, the coat, the dress, the pullover, sandal, shirt, the sneakers, the t-shirt, and the trouser. And you can see that just to have a comparison on the if our test set and train set are quite similar. So just in terms of the mean pixel of the intensity, they are quite similar. So it was good to have some similar object on the train and the test set. And after we will go to the linear binary classification that just Yoni presented you just before. So what are you on now? Oh, good, Peter. Happy. No, sorry. I'm here for this. Okay, so now we have machine. I hope machine is Google a lot. Maybe we managed to get it. Okay. Can we go to the linear binary classification? Yes. And yes. And I know your skill in R. I know this. Okay. Okay. But you can install without Anaconda, I think. Are you sure? Because Anaconda, I just try to help. Do you manage to install Anaconda? I'm trying to, because install TensorFlow, I think you have, what was the line of code? What we did there last time? Question mark install. Have you tried to put auto instead to conda? Something like this when you do machine? Because when you do install TensorFlow, it proposes you auto virtual environment of conda. Yes, so I suggest to try to do install TensorFlow method auto just to see. Okay, you cannot find a get the error and try to install. Okay, so you need to put to first install to do this. You need to do TensorFlow. So first you need to install TensorFlow when it doesn't work, and after you can use TensorFlow. You can see what I'm doing here. Can you try to write this? Yes, but I think you need to first write. You need to first to do install the packages. TensorFlow. Okay, I'll keep going the tutorial. I will try to help you just after. Okay, okay, machine. Okay, the binary classification. So we select to do this. We will work on the. No, you managed to do the. Sorry, I'm jumping everywhere. So you managed to get the distribution of the mean pixel for each. Close this. So I get this for each close. And we go to the binary classification, okay? Okay, for the linear binary classification, we first select on the means data, we come back on the fixed data, we select the figure 3 and the figure 8, and I can see that I have 6,000 around roughly 6,131 3 and 5,851 8. Okay, and now after we take, I show you all in R, which is easy. We have an image 28 by 28, and in fact we will not use the what you will do is a convolutional neural network. We're just doing flatten this matrix. So we have this matrix 28 by 28, and we want in fact to have a long vector. So each image 28 by 28, our features will be each pixel. So 28 by 28, it give you 784 pixels per images. And so this, I will put this matrix in a long vector. So to do this, we just, with the C, you collect, and we collect all the elements, for example, for the first images, and you put this in a long vector. So by doing vect image 1, I have the pixel for all these images. So I just plot the first 20 pixel, but no worries because it's 0, is because on the border of your images, you don't have any intensity. So it's normal you have a lot of 0 at the beginning. And now I put this in the matrix. So by this code, you have now a matrix, which was first an array, and now we transform in a matrix. So you have this 6,131 image, and for each image, you have the features in column, which is each pixel. Make sense? Let me know if it's not clear. And I just plot now this matrix. So is meaning I plot just the 6,000 images and with all the pixels. Not very useful, huh? Quite a long way. Why is long like this? I don't remember. Did you manage to get it? So you get something like this. It's not the nice label on the X and the Y, because we have this, you have, because I rotate, so this in the Y-axis should be the 784 pixel, and each this is images, I think so, the 6,000. Yes, for the image, in fact, the rotate, when you do this, because if you don't do this, you can try to do it. I will show you maybe an example here. For the shoe, you can see the shoe. If I don't do this, and if I rotate, so when I do this function rotate, here is rotate. It's just to rotate the image, because if I don't do the rotation here, I will show you. I will try the X. If I can plot that's my shoe. You see the shoe? Graph. So yes, so I just define a function rotate to rotate my image to have a good direction. That's it. It depends on the data are stored, in fact. Oh, 42 already. The time is flying. Okay. Back to the business. We want to do this classifier because you want to work on this and I want to explain. Okay. Yep, yep. We are here, we are there, we are there. Okay. So this is for the digit. What was the digit? This one, I don't remember. The positive, we put the positive is a 3. Yes, positive 3. And we call it positive trend is 3 and the negative trend is 8. So we do the same with the 8. Okay, and we have 8, we transform. And now I put all the data in the same matrix because I want to have my design matrix. When you regression or classifier, you have your design matrix. So I will have the characteristic of the digit 3 and after the characteristic of the digit 8. Okay, so I just do R bind to bind by row the two matrices. Make sense? So in A, I have all my features for the 3 and the 8. But first we have the 3 and after we have the 8. Okay? Okay. And now I add a column, a first column of 1 in the matrix A. Could somebody tell me why? Even I put the stuff just to see if there are some people still there. Why I put a column of 1? Nobody? Okay. Ah, very good. So, it is intercept in the regression. Yes, and in the deep learning framework, machine learning framework, is called the bias. Okay, so you have each row is an image, the 3, the 8. Each column is the features. We can say in the regression statistic is explanatory variables, the predictors. So is the information of the intensity of each pixel. And we add a 1 on the first column for the intercept. Matt, make sense? I can come back tomorrow on this. Okay, so now I have my design matrix, okay? And I want to solve, I want to do a linear model to classify, but my outcome is the 3 and the 8. But 3 and the 8 is not the outcome because it's just to say is a positive or negative, to say +1 or -1. So we need to code the response variable, which I put in Y. So I will, in the Y, I will put just +1, +1, +1, +1, and after -1, -1, -1. Make sense? And I just solve the least square problem, which is given by, if you see my screen, this I want to have to find the beta, which minimize the least square. And A is my design matrix. Make sense or not? And the solution of this, if you're looking at the notes from the chapter 1, the solution of this, you know, that is defined by the generalized inverse, which is denoted by this here. And in fact, you know that in beta, in fact, you know this, that if the matrix is inversible, I can write this in R very quickly. Beta is equal to A transposed A inverse A transposed Y. You see it? So the solution is given by this, and in fact, this symbol, this A, this one, and you can, looking at this, as the generalized inverse, which is given by the moon Penrose, is, I can show you this very quickly, just a little bit some math. I hate to be on the rush, but the life. This is equal to this. That's it. So we have all now. Are you confused or not? So this is a solution. And to get the solution, it's quite easy now. You got this by the function GEnv. And if you're looking at a function GEnv, this function GEnv gives the generalized inverse of a matrix. Calculates the Moore-Penrose generalized inverse of a matrix X. So when you do GEnv of a matrix, it gives you, in fact, this object, A transpose A minus 1 A transpose. So to get the beta, I just need to do GEnv multiply by Y, and I get all the beta. And what is the dimension of my beta? Question. Just to see if everybody is okay. Yes, thanks, guys. So we have 744 features plus the intercept. Perfect. So I can plot the beta, I can get the solution, and I plot the beta. You manage to get it. And after we can do the classifier in one code of line. Okay, the G inverse maybe could be a little bit longer. I don't know, for me, it's longer. And now, with this simple classifier, so you get it. If I'm doing this simple classifier, which I call classify, if I'm looking at the code, what it's doing, now I have a new image. A new image is representing in our context by some features, 784 features, so which is there, and I put a 1, this classifier, which my function I create. If I give you some beta, it will compute the predictor, which is X transpose beta, and X transpose beta in R I can just doing by this line of code. The sum of my X with a 1 on the first multiplied by beta, and I'm looking at if it's greater than 0, I will say is positive, and if is lower than 0 is negative. So with this simple function classify now, if I give you any, if you give me any images, I can try to know if it's a 3 or an 8. So you give me an image of a 3 of an 8, you don't tell me this, and I can check it. So I am doing this for the positive to see if it's working. So I take the first image, which was the 3, and I try to classify my classifier, I say is a 1, is a positive, so a 3. And the negative train, I take an image with the negative, so I know that is negative, and I try to do my classifier and give me a good answer. So, but I want to know if it's working on data I haven't seen it. So on my test set. So the data I haven't used to build my classifier. So it give me what it give me. Yes, 1,1000 positive and 974 negative. So now I want to evaluate if my classifier is good or not. So I will compute the true positive. And I did a mistake in my code, but Anne, give me some. You're right, Anne. So in the code you have seen, maybe you have res positive. So I initialize a vector, and I initialize like a very bad thing. I put a true. But when you initialize the true is coded in R by 1. So I need to initialize to null. So I did a mistake in the R code I gave you. So you need to change the true by a null. And you should get a true positive, which is I have 968 true positive. So from my positive test, so is the meaning that I have the 3, I did just 42 mistakes. You got this? Did you get this? We have 5 minutes. Yes, Peter got it. Okay, and now the same for the negative. I did a mistake, so I get this one. So now the task 4, we will stop after the task 4, and you will finish your track because you will finish the track, and I will give you the solution after. Task 4, what is the accuracy? Okay, to clarify, question, Garth, blah, 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 blah. To clarify, is the 0 in the classify function the theta in the lecture early? What is the 0? What I see in my classifier. Oh, no. The theta in the, okay, I just check the notation. Good question. I check very quickly, okay? The 0 in my function is just to say it's positive or negative. So I just try to see the notation from the first. The theta maybe is a beta for us. I check. If I understand well your question, classifier ad hoc. Yes, theta, right. Yep, exactly. But in this classifier, it was make sense that we have a +1, -1, that our threshold was 0, positive, negative. Make sense? Yeah, okay, good. So task 4, what did you get? The solution? You managed to get it? Task 4, it was to find what is the precision, recall, and accuracy, and the F1 score. So I got the precision, which is 96 a record which is 95, and a F1 which is 95. You can see that it's quite good. And it was pretty good with something very simple, in fact. With just something very fast and not a lot of information, just a pixel, no location, nothing fancy, and we can manage to classify pretty well the 3 and the 8. Okay, my advice, you will get a lot of new information now. It will be, at the beginning, start slowly, but we will have more and more information. I suggest you to, after each lectures, to do your own summary. Just put the main new topics you have heard today, and you just say, for example, F1. Maybe you never seen the F1. You never seen maybe before the record and so forth. So do some summary. Okay, to not be completely lost. Okay, any question? Because just it's 5, so you will go through by yourself the end of the on this PRAC, and during the consultation hours, if you have some trouble on this PRAC, you can ask me, and I'll be very happy to help you during the consultation hour if you have some trouble, something to understand on this PRAC. Okay. Plot show. Peter. Okay, this plot. Okay, this plot, in fact, so Peter, in this matrix, mat pose train is the matrix of all the images which was, say, positive. So it was the figures 3. So we have a matrix which was dimension, it was 6,131 rows, which is the